Lord, we give you thanks today. We thank you, Lord, for making it possible for us to be here again. Thank you, God, because you are a faithful God. Thank you for your saving grace. Thank you for your mercy. We worship you, Lord. You are worthy to be praised, and there is none like you. Take all the glory this evening. In Jesus' mighty name, we have prayed. Amen. All right. Okay. So, once again, good evening, everyone, and welcome to our source code management class. Before we get started, I want to confirm: did you all receive this invite, the invite of this class, and onto your email, to your email address? Did you receive it? How many of you received the invite of this class? Let me see. I think if you're in this class, you should have received it, right? Right. So today, oh, thank God. See that? So that's good. Okay, got it. Perfect. I like that. Okay. So which means that if you look at your calendar, you should be able to see. Okay. That. Okay. That's good. That's it. So you didn't. Strange. All right. So that's it. We are going to start looking at source code management platform today. In fact, source code, okay, distributed versions control system. What is it all about? And why is it important for you as a young IT professional to understand what distributed versions control system is all about? First and foremost, you want to understand what DevOps is, right? So DevOps is a collaboration between developers and operations. And we understand that developers are responsible for developing and updating the source code of the application, right? So they are the ones who are responsible for actually coding the application, writing the application using popular programming languages like Python, Java, C#, and C++. Okay. Now, imagine that you are working with a team of developers. Let me not even go far, right? So Darwin, Daniel, Moses, and Udwag are all part of a developers team. Daniel is located maybe in Lagos State. Maybe Hassan is located somewhere in Abuja, and Darwin is in the USA. They are all developing source code for one application, for one company. The question is, how can they collaborate? Is there a tool? Is there a technology that can enable the team to versions control, okay, to versions control their source code? So is there a mechanism that can enable us to what, to versions control, okay, to versions control our source code? Udwa, can you make sure that Musa Isa is able to join? I think it should be in this class instead. Can you check, please? Okay, thank you. Okay. So, yes, okay. Versions control is what we are looking at. Now, every application you see today, even the documents, do you know that the Word document that we are all working on, if you go on Microsoft Word and you click on versions history, you will see, okay, in fact, you will see the various version of that document from when it was created, okay, per time. So each time there is a change in that doc, what happens? It automatically saves. So this is to prove to you that versions control is so important in software development. And that is why today, if you just take a step back and look at, for example, right, your WhatsApp application. Just think about, how your WhatsApp app was 2 years ago to what it is today. So each time they add a feature, what happens? That application is going to what? Is going to update. So each time there's a feature, there is a new version. That's why in most cases, sometimes what you may be prompted to say, oh, you know what? You're maybe what? Okay, you're using the outdated version of Chrome. How many of you have gotten that kind of a message prompting you to update your Chrome browser? How many of you? So if it is not Chrome, it's definitely okay, other applications and software that we use on a daily basis. So distributed versions control system is one of those tools that enables developers to collaborate. Developers, QA, and DevOps to collaborate on what? On source code. Now, let's say you get hired in a company like PayPal, right? If they have distributed versions control system in place, and say, hey, Johnson, can you please look at that payment repository over there? We want you to update a particular file, right? Did you know that though you joined the company maybe, let's say, January 1st, 2024, you could what? You could actually see who created that file. In fact, who was the first person to write in that particular file? Some 5 years ago or some 100 years ago. So what? Versions control is what? It's all about time and identity. And then what changed? So for example, now, have you noticed that when you are working, for example, on a Microsoft Word document, each time you touch anything in that file, right, and you're about to close the file, if you don't have auto saved enabled, what happens? Microsoft is going to prompt you, hey, okay, do you want to save changes, or you want to what, or you just want to close the file and go? Why? Because the system has realized and detected a change in that file. So what we can consider this file as a source code management, or as a file that is being version controlled. Now, so why is versions control so important in the world of software development? Because of course, right, as developers are updating, okay, the features of the application, right? That's how the version of the application is going to change. So for example, okay, if you look at your WhatsApp application as a date, you realize that sometime late December and yesterday, there've been some features added, like voice chat, right? And locked chat. These are features that were added. But now, what happens if WhatsApp wants to go back to the previous version? Can they go back? Now, in the world of tech and in Kubernetes, we refer to the word go back as as a rollback. Now, this is so practical in software development and deployment. Why? Because now look at something. Let's say, okay, WhatsApp had a particular version of its application in production. Now, production simply means, okay, this application is now in the hands of the end users. But the question now is, WhatsApp wants to deploy a specific version of the application. Maybe what? WhatsApp version 8.3. In version 8.3, we are what? We are simply what? Releasing one feature. This feature is maybe parental control. Okay? Now, WhatsApp deploys the parental control feature into production and bam, something happened. The whole WhatsApp application is down. Now, when versions control is in place, when versions control is implemented, it becomes so easy for what? For WhatsApp to simply what? Roll back to the previous working version of that application. Again, what? Everything is source controlled. Right? Source controlled. It's like, for example, how many of you have used a feature history, okay, on your Microsoft Word document? Have you seen where, for example, what you can see a document and what you can restore, right? Maybe, you know, okay, what? A specific version of that document 2 years ago. It's possible, okay? As long as what? As long as the document was what? Was being versions control. I'll show you guys very soon, right? On what? On Microsoft. So we live this every day. And I can't say like every day we live what? We live versions control. Because what? We are improving ourselves, you know, learning new things and know, like I'm saying, adapting. So our life as human beings is what is all versions control. So in a software development team, let's say, okay, what? All of us, we are 20 in this class, what? We are all collaborating on a particular, you know, project, on a particular, you know, okay, project, and we are what? We are distributed across the globe. So we are what we call a distributed, okay, what? A globally distributed team. Udora has a task to develop and what? And upload. Now, the word upload in the world of source code management or Git is what is called commit. So to commit means to simplify. Like, you know, when you take somebody to the court, maybe you take a girlfriend, somebody in this class is getting married this February. I don't know. I've forgotten. No, not in class. Yeah, I think it's in this class. Okay. So that guy is going to take that lady to the court and what? And commit, right? You know what you want? You're committing the rest of your life. That means that you are sure. So in the world of Git, when you run the command git commit, you're what? You know what? I am signing this change. So as you commit the code, what happens? Git is going to record the time that commit was done and the author who committed this particular change. As a matter of fact, who made this change. Now, it's like, for example, you know, I have seen some of you what? So each time you touched any of the documents in LionTech, what happened? That document will automatically update and record your name as what? As to who recorded or what? Who touched the file. That is what? That is a practical example of versions control, where one, we are able to what? To identify accurately all the actors collaborating on a particular source file or source code, right? That's one. Two, the distributed versions control system is able to what? To record exactly what changed and when it changed. And of course, who changed it. Okay, so what? Versions control system or Git is what? Git is all about, you know, what is happening in our source code. Take a very simple example, right? Maybe, you know, you hire a junior DevOps engineer, they get on and maybe what they, let's say, okay, what? We are working on a particular file, okay? This file is called payment or payment what? Payment method. And now on the payment method file, we have a list of payment methods. So we asked him, oh, please, can you go in there and add Stripe as our new payment method? And then, but he goes in there and know what? He deletes all the payment methods. And then what? He saves it and commits it. Normally, without a versions control system in place, it will be so difficult to restore that file. But if we have a versions control system in place, we can what? We can just go like 2 hours back. Hey, was there any change in this file 2 hours back? Yes. Therefore, what? The change that Daniel made 2 hours ago, and the change that the new engineer can what? We can restore back our source code to its previously working version without any issue. So Git introduces what? Git simply introduces the concept of collaborating together on a source code. Git what? Git also enables what? Versions control. What does versions mean? It simply means to what, to be able to track the changes on our files and documents per time. Not just per time, per who, what, and when. Okay? So Git can accurately tell us who made a change on this document, what was changed, and when it was changed. And let me tell you why sometimes people get fired at work over Git. Let's say you had a particular, assignment and task you had to do. Okay, maybe what you had to do, change a particular file or create a particular file and and then upload it into the company's, Git environment. And then you had a deadline. So maybe you did the work and everything, but you came like 2 hours later and then you uploaded. And then they ask you, hey, when did you do this? Oh, it's okay, you know what? I got on my project yesterday. Now Git is going to prove you wrong because the moment you run the command git commit, it recorded exactly. So if you run git commit maybe yesterday at 8 p.m. and you only had to push the work at 6 a.m. the next day, Git is only going to record when that commit was done, not when you pushed it. So it's like, for example, if you take a letter to the court and you guys sign your court paper, that is a commitment. The judge doesn't care when you guys get home. So if you like, you can go to some place and just spend the rest of your life there. No worries, but it is recorded that your marriage was entered into registry at this time, as at the time that you went there. So that is the power of source code management. So it gives us the ability to be able to monitor change on our files, look at what has changed, and also collaborate together on those files. So you hear of concept in Git like pull request, Git push, Git clone, right? Git commit, Git lock, Git config. These are all some common Git commands that we are going to, start looking at. But before we do that, let's go ahead and see, what we have as a presentation. So somebody wanted me to share my screen now. I'm going to share. Great. So now let's look at what we are talking about here. So this is Git for beginner and how to take care of your source code. Again, So what? Please take note of all the, okay, the terms in red here, like what? Central and distributed what? Versions control. What is Git and what Git is not, okay? And what Git terminology, like what? Master, origin, commit, branch. What does it mean? Playing fair with your team, merge and rebase. Now, this is where, most teams have issues because normally in most working environments, you cannot merge your own code, right? But however, what are some of the Git best practices? Please, this comes in most interviews, okay? This comes in interviews again. Git what? Git basics right. Get your basics right. Git branching. Everything you see here are a must understand. You need to get it and you must get it right. So why versions control? Now, just what I was explaining before, right? Now, imagine that we have this system. Like in those days before the coming of the cloud and cloud storage system. I don't know how many of you used to use, is it Dropbox? Yeah, Dropbox. So previously, right, we used to have developers like this, or what? All committing their code on a central server. We call this a recipe for disaster. Why? Because if we have all of these developers committing their code in one area on one server and not returning the latest version of their code, what happens if this server goes down? So what this was the concept of the centralized what? Distributed versions control system. Okay, so what we are going to look at, what is the difference between the centralized approach and the distributed approach. So versions control or revision control or source control is what it's all about, merging what? Multiple versions of your source code used in all real-world projects and for what? For team collaboration. Some well-known versions control systems are what? Are CVN and SVN. Okay, so what we have, centralized versions control system, and we have what? The SVN, okay, and we have Git. So versions control system act great as what? As a time machine. That's all about it. So each time something changes or something changes on the file, the time that change was made is recorded, plus who made the change and what changed. Okay? Again, what? With a time perspective, it gives you an option for going back and forth, okay, between versions. You can do what we call what? A git diff or git revert. Versions control is essential for working with your team. It greatly simplifies concurrent work and merging your changes. So when you hear the word merging, it's a term, right? That's a new terminology. What does it mean to merge? So whenever a change is made, that change must go through what they call a merge request. So think of it like this, okay? You work for a company and you are the auditor, but what? But not the senior auditor. You have, gone through a particular document, done the auditing, but what? You cannot submit a request. Why? Because your senior auditor must sign off on that particular document. So without his signature, you cannot submit a project. That means that is what? There is need for a merge request. So versions control, central versus distributed. Now, when you look at the centralized versions control system, it simply means that we had one central server. okay, where all the copies of our project were saved. So think of this like probably a hard drive on your computer. Why it is so important and so nice to have it on your computer, but what happens if your computer is stolen? It means that our project is gone, and the project is going to be delayed. And of course, we've also expose our services to the internet. So there's also a security concern there. So to understand distributed versions control, it's very, very important to also first of all understand the DVCS, centralized versions control system. However, in today's industry, the most popular versions control system is Git. Okay, it's Git, and Git is a distributed versions control system. So the typical workflow in the case of a CVCS is so all you do is you check out the source file, edit it, and then check back in. Where it means is that programmers no longer have to keep many copies of files on their hard drives, usually because of the version control tool can talk to the central copy and retrieve any version they need on the fly. But the big problem is that most of its functionality depends on you being connected to the central server, which means that you can't really work, okay, with CVS without being on the internet. However, with a distributed versions control system, all you need is to download the code. In the world of Git, we refer to that action as clone. Okay? Clone the code. To clone means to create a copy. But in the case of Git and source code management, to clone here simply means that we are going to simply download, okay, a copy of a particular file or directory. With distributed versions control system, the system doesn't necessarily rely on a central server to store all the versions of the files. Instead, every developer clones the code, a copy of the repository, and has the full history of the project on their own hard drive. Now, what does this mean? To have a full history of the project. So think of it, okay? I just got onboarded for a project at PayPal. I have a repository. If I clone it, I can see, when this file was first created, the developers working on this particular file, everything about the file, the version's history, I can have access to it. The typical workflow is clone, pull, commit, and push. Now, what does it mean? What does it mean to clone? We only clone a repository once. Now again, what is a repository? A repository is just a location that holds files and directories remotely. So in this case, we can say clone, pull, commit, and push. So once you clone a code, you can edit a particular file in that code, you can commit the code, and you can push the changes. So how we are going to be implementing this workflow is what we are going to look at in the next video. So of course, you can see, what is Git? So first Git is It's a distributed versions control system. Git manages changes to a tree of files over time. See that? Over time. So this is the most powerful, usefulness of Git. Git is especially this is for distributed, development, large file counts, complex merging, and making branches and quickly switching from one to another. It's very fast and robust. Why? Because in most cases, you don't require the internet or to be connected on the internet in order for you to do Git. You can, of course, count on Git. So companies like Facebook, Twitter, Google, and even that new stuff in Bangladesh or Cameroon or China isn't it? Git workflow can be a bit difficult getting used to it. Since people have long been working on large code base with SVN and CVS. Also, people in general are not comfortable with too many commit or comments, right? So we're going to look at all of those options in just a moment. But let's look at what the Git internals behind the scene. So we have established that this is what Git is going to do for us. So it's the distributed versions control system. I'm going to share a PowerPoint with us. Now, let's look at what we just explained diagrammatically. So now, let's say we have, this actor. If we want, we can call him. Okay. Now what? We have that actor. Okay. And we have this actor. Now, let's imagine that they have the company GitHub account access. Okay. And the job here is what? The job here is for these actors to either start a project and commit it to GitHub or clone an existing project in order to commit it to GitHub. So in this scenario, let's say we have okay. So we have actor 1, actor 2, actor 3, and actor 4. Now this is our GitHub account. Okay. And on this account, we have we have a GitHub organization. Okay. And under this organization, we have we have repositories. So that very, very important. So now we have this actor, okay, developing his application and then pushing it here. And we have, it's pushed. Then this is pushed. See that? So all of these actors are are actually, contributing or pushing, changes to the source code. So yeah, they are running They are running Git push. So that's the goal, to be able to have these 4 actors contributing to the project. So there are 2 things to note here, and the steps to follow. So now, if the developer is actually maybe building this project from scratch, then of course there's no point to do a clone. Why? Because you are building from scratch. However, if the developer or the DevOps engine is what? Is just is what? It's going to just start maybe developing an existing project. Then what? It's going to be a big deal. Why? Because to start a project in Git and to be able to actually contribute on a project are two different scenarios. Okay, two different what? Two different scenarios and the processes that are involved in that particular process. Now, what commands will he run here? Git what? Git add, okay? Git commit, and we have what? Probably, okay, git push. Okay, that. So the user is either going to what? Clone the repository and then what? Run, probably, do his own modifications, add what? The changes to the staging area, and then what? Then of course, they're going to what? They're then going to be able to commit the code to a source code management platform. So now, enough of most of these lectures or talking. Let's what?